We saw previously that we could create templates for functions. We can also create templates for classes. So let's start off by defining a template for a class. Template, we use the keyword template, and then arrow brackets, class T, to indicate that this is for a class that's going to have a placeholder T for the data type. I'm going to define my class my pair, like I usually would. Open parentheses, close it with a semicolon. And it's going to have variable T. So I have the placeholder T for the data type A, T placeholder for the variable P. And I'm going to have a constructor, my pair, that takes in any data type for variable first and any data type for variable second. And it's going to assign A equals first, B equals second. I will also define a function that returns a placeholder data type indicated by T. The function is called getMax. GetMax initializes a variable called val, and val equals A greater than B, and returns, so if A is greater than B, if that's true, it returns A, otherwise it returns B. So we're going to return the value. So we've just defined a template class, and I'm going to call it my main function. So I have my pair. The class my pair is going to create an object, my object int, and I'm going to pass in two variables to the constructor, 92 and 75. And I want to figure out which value is the largest, so I'm going to call the getMax function, my object int.getMax. If I run that, I'll get 92. So the getMax function returns 92 as being the larger value. I can do the same thing with so this was for int. I'm going to do the same thing for double. $33.5, and this is 72.9. I'll need to rename this object to double, and this is my object double. If I run that, I'm expecting that the second value will be returned, and it does. And as you can see here, the template worked when I passed in integers and when I passed in doubles. Now let's say I wanted to pass characters or strings, but I wanted to do additional manipulation of those arguments. What I can do is not only create a template, but create specializations within the template. So what I can do is I can update some of the syntax a bit. So I'm going to copy this template. And the difference is going to be that I'm going to call template, but I'm not going to specify the class or the placeholder data type. I'm going to still call it class myPair, but then I'm going to specifically define what data type it's allowed to receive. So this template will be allowed to receive car data type. And instead of the placeholder T, I'm going to update that with car. I'm also going to update it here with my constructor, car. I want to do an additional manipulation of these parameters. So I'm going to use a function toLower, which if there's any uppercase character, it's going to change it to lowercase. I'm also going to change this one to lower. Now this toLower function is within a library called ctype. I'm going to import #include ctype. dot h. So I can use that to lower function. So this is going to import in the C-type library. And for our getMax function, I'm going to change t for char. So I'm going to specify what the data type is, char val. And this logic will remain for characters. So characters behind the scenes are encoded with some value. And so this logical comparison is still valid. So let's try out our function. This time I'm going to try it out with char. So I'm going to define my object char. I'm going to pass a, and I'm going to pass lowercase c. So capital A, lowercase c, when I construct that object. And then I want to print out the largest character between the two. I'm going to call getMax. If I run that, we can see that it returned char c. So between A and C, it returns C. We've used template specialization to construct a template that can accept any data types, but we have a specialized template that can accept char, and it performs a specific processing for the char data type, but ultimately it runs the same logical operation.